Hello friends, let us discuss a very important terminology in geography called as a temperature inversion. Temperature inversion is a phenomena which we can observe in our day-to-day life. Specifically, it is observed in the winter. So let us discuss what is it. This terminology or this phenomena is very much related to one more concept called as a lapse rate. So before going to the temperature inversion, let us understand what is a lapse rate. Lapse rate means in the troposphere, as we move vertically upwards, temperature decreases. So decrease of temperature is like 6.5 degrees Celsius at 1 kilometer height. So as you move upward above 1 kilometer height, the temperature decreases by 6.5 degrees. This is called as a temperature inversion. Or let us say 1 degrees decrease at every 164 meters. So this is a vertical change in the temperature. So friends, what happens in the temperature inversion? In temperature inversion, generally this lapse rate gets reversed. Lapse rate gets reversed means what? It means instead of temperature getting decreased, it increases as we move upward in the troposphere. So this inversion of lapse rate is called as a temperature inversion. Okay. So initially that we saw that normally what happens when sunlight hits the surface of the earth emits long wave radiation. Because of the long wave radiation, what happens? The air above the ground gets heated and it travels upward. Upward, you have a cold air which comes down because cold air is heavier than the warmer air. So this cycle of convection goes on repeating itself every day. So, as you are going down at the surface, you have high temperature. As you are moving upward, you have a low temperature. So, in this way, general lapse rate is set. But in temperature inversion, this phenomena gets reversed. As you are moving upward, temperature increases, and you go close to the ground, temperature is cold. So, why this thing happens? Okay, so you can see over here normal lapse rate is getting reversed. Okay, so why this is happening and when this is happening? This generally happens on the cold winter nights, or winter season is very much favorable for the temperature inversion. Now why winter season is very much favorable to temperature inversion? Let us understand this. Okay, so during the winter season what happens? Skies are clear and ground is very cold. So as you know, sun is on the tropic of Capricorn in the winter season. So northern hemisphere there is generally winter. So what happens? Earth loses its heat initially very quickly in the daytime. So for example, when evening is being set up, Earth has almost lost its 50 to 60% heat through long wave solar radiation. As night approaches, this process quickens further, and when further nights get deeper and deeper, let us say in the morning 3:30 or 4 o'clock, Earth has lost its heat completely. So when ground has lost its heat completely, this heat is being captured by upper layers, and the layer of the air which comes very close contact with the ground, it gets cooled and cooled up. So why it is getting cooled up? Because ground is already cold. So because air comes in touch with a cold ground, it also becomes cold. So here you can see in this diagram that this is a temperature inversion where ground has ground has become cold, and the air which comes in touch with the ground also becomes cold, and the layer above that ground becomes warm. So this is a warm layer. So what happens now? As you know, Earth does not have the heat content. Earth is completely cold. Now Earth cannot warm the cool air above it. So there is a complete breakage of the convectional current cycle over here. So you can see normally air is rising, warm air is rising, cool air is coming down. This cycle has been broken. So atmosphere has brought to the complete stagnancy because of this. So what will happen now? As you guys know, many atmospheric phenomena are because of this convection. Like a particular pressure is being set up, either low pressure or high pressure, it is because of the convectional currents. So when air rises upward, then only low pressure will be set up on the surface of the ground. So now there is no upward movement of there, so there is no low pressure on the ground. Since air is not rising upward, you can see there will not be any rainfall, because we know that for rainfall to happen, air needs to rise upward and upward. Because of that, it gets cooled and cooled, and when air gets cooled, moisture gets condensed and there is a rainfall. So now there is no any kind of precipitation, because atmosphere is at certain level of stagnancy. Stagnancy does not mean static, but there is a very low movement of air. Getting it? So what happens in this condition? In this condition, when atmosphere is at stagnancy, cold air is below the warmer air. So whatever content of that cold air is there, which is in contact of ground, it will show its characteristics. So for example, cold layer contains moisture. So on the surface level, whatever dust particles, whatever pollen particles will be available over there, this moisture get encircled around this particle, and it will create a situation called as a fog. So fog will happen. So fog, you can see a type of very mild clouds which has formed on the ground surface. Okay. So fog forms because of the temperature inversion. Getting it? Also, if you see, if there is a pollution, so pollution will also get trapped in that cold layer of the air at the surface. So pollution won't be able to mix with the other parcel of the air. So pollution will get trapped in the lower parcel of the air. So because of the temperature inversion, you will see, you will feel more pollution. In that, if there is a fog and pollution, they get intermingled with each other, then what will happen is a smog. Smoke and fog, we'll call it as a smog. So these smoggy conditions are very dangerous. So these temperature inversion creates this smoggy condition, because of which lots of accidents happen on the highways. The very good example of this is Delhi Agra highway. In winter, you will see lots of temperature inversion and smoke coming from nearby brick kilns and vehicles. So lots of accidents will happen on Delhi Agra highway. Okay. So this is a temperature inversion condition. So this temperature inversion condition remains until and unless sun again rises and heats up the land. When sun heats up the land, again land gets the heat and it starts warming up the cooler air above it, and then temperature inversion will be completely dissembled. Okay. So in this way, temperature inversion phenomena happens and it gets removed because of the sunlight. Now these temperature inversion phenomena are very common at the places like valleys. For example, you can see over here, if you might have seen such temperature inversions when you have went for the trekking, or at so many places on the mountains. So what happens over here? In the winter night, mountain tops loses heat very quickly compared to valleys. So at the night, mountain top become very cold, and the air which comes in contact with the mountain tops, it becomes colder and colder compared to air in the valley. As you know, cold air is heavy, so it descends down into the valley. So valleys become very very cold. Getting it? So what happens in the morning? Sun comes up and it heats up the mountain top. So mountain top gets heated very quickly, because sun rays are completely vertical. As soon as sun rises, it mountain top faces it. So what happens? Mountain tops heats very quickly, and air around the mountain tops heats very quickly. But valley, deep down in the valley, you still have a cold air. Getting it? So at the valley you have cold air, and at the mountain tops you have the warm air. So in the morning time, around let us say 7 to 10, between 7 to 10, you will have a temperature inversion conditions in the valleys. Okay. So when sun comes to the 12 o'clock position, then what happens? Then it vertically heats the valleys. Then valleys will start heating, and then this temperature inversion condition will completely dissolve. Getting it? So this is how temperature inversion is very day-to-day phenomena which we can see everywhere. Okay. So this is about temperature inversion. Thank you.